Hi everyone. Today is Friday, October 6th. Happy Friday. We are behind schedule. We haven't started 4.3 yet. So today we're gonna talk about 4.3, and then next Monday we'll talk about 4.4 and 4.5. So we don't have time to review. So yeah, we don't have time to review. So let's see. But you know how the practice exam and exam look like. So you can review at home. And if you have questions, feel free to come to ask me. Okay? All right. Let's see. Okay. So 4.3, the chain rule. Okay. So big idea. The derivative of a composition of functions is the composition of the derivative of the outer function with the inner function times the derivative of the inner function. Big skills. You should be able to compute the derivative of a composition function. Oh, sure, yeah. All right, so let's review what are the derivative rules that we have learned. The first one, we have the power rule, right? And the derivative of x to the n is n times x to the n minus 1, right? And we also have the exponential function e to the kx. And we bring the k, the constant coefficient of x in the exponent, down in front, and then e to the kx. Do you remember I said father looks like the sun and father has mustache, right? So you still have e to the kx. So don't put e to the kx minus 1, okay? Don't change the exponents. So that's power function and exponential function. And then we have the product rule. So uv prime is u prime v plus uv prime. Remember, two students go to the restroom together, they go one by one. They don't go together. So this is the product rule. And then we have the quotient rule. The numerator, very similar to the product rule, but we put a minus sign in the middle. So, and the denominator is what? V squared, yes. So far, so good, everybody. Today, we're gonna learn chain rule, okay? So, chain rule is, you use chain rule when you see a composite function, okay? So, a composite function is you have an outer function and an inner function. You see, this is like a composite function. You have something raised to the 50, and your inner function is the thing inside here, the parentheses, right? In this case, you let u be the inner function. Okay, so we let u be the inner function. So g of x is the inner function. Then dy dx is dy du times du dx. Look at this formula. Do you see you have du in the denominator and du in the numerator? If you cancel them, you just get dy over dx back, right? So from the formula, it kind of makes sense. This is the chain rule, okay? So derivative, and this is the same thing, represent the same thing. So the derivative of the composite function, y is the composite function, equals dy du. So the derivative of f, and then you plug in u, g of x, times du dx. Because u is g of x, du dx is just g prime of x. So these two expressions just mean the same thing. Okay, everybody? So, what does that mean? So it means all the formula we learn, now we change to So the new formula of chain rule will be, the formula is same as before, but you multiply by u prime at the end. For example, our power rule. So u to the n prime is now same as before. We put the n in front and then u to the n minus 1. Is that okay, everybody? This is same as before, but then you multiply by u prime at the end. Okay, so same as before formula, but you multiply by u prime at the end. Typical mistake is students put the u prime here. No, u prime, you multiply it at the end by itself, and it's just u prime. Don't put it inside the power. Okay, everybody? Therefore, e to the kx. So now my x is like u. Okay, let's just use e to the u. Well, e to the u is derivative of e to the x is e to the x. So derivative of e to the u is e to the u. But you need to multiply by u prime at the end. Is that okay, everybody? So that is why you can use this formula to get this formula. Because e to the kx, you can think of kx as u, then it equals to e to the u times u prime, but kx prime is k. Do you see that, everybody? So actually, I tell you this formula, but actually how to get this formula is from the chain rule. Okay? Yes. So this is the new formula when we have a composite function. And when you take a derivative, you look from the outside to the inside. The feeling is really like you want to peel an onion. Okay, look at the first layer, the outer layer, and then the second layer, and then you keep going. So today we will have lots of examples. So the first example. Do you see this is a composite function? You let u be the inner function. So this is u. So you can write down u as 3x squared minus 5. Remember, put them in the standard form. Yeah, x to the minus 1. Good. Plus e to the 4x. That's the u. So far, so good, everybody? And then derivative. Here, u to the 50. You see we're using the power rule and chain rule, right? So u to the 50. My suggestion is, you don't need to put u to the 50, okay? So you just write down exactly what the u is. Okay, so the derivative of u to the 50 is 50 u to the 49, right? So 50 u, but when you say u, actually write down what is the u. Your u is 3x squared minus 5x to the negative 1 plus e to the 4x. That's u to the 49. And see, 50 u to the 49 times u prime, right? So write down your u. Your u is 3x squared minus 5x to the negative 1 plus e to the 4x prime. Okay? So even though you say u, but you don't write down the letter u, you write down exactly what the u is. The reason why is your problem will get harder and harder. You might need to use chain rule multiple times. So if you write out a lot of u, different steps, your u means different things. Also, before, when you use quotient rule or product rule, you also see the u there. So I also suggest don't write the u and v. Write down exactly what that expression is. Okay, so then you don't have abuse of notation. Question?
So, in that what you just said,
Yes.
isn't this u prime? So why did you write up u?
Yeah, u prime. U
So
prime.
shouldn't that be like the derivative of that?
Shouldn't be derivative of that?
Yeah.
Yes. So next step, we write down the derivative. So each step, let's just do one thing. Don't jump steps. If you jump steps, it's very easy to make mistakes. And in the exam, I give you partial credit. Okay, everybody? Yeah. Oh, I see. So you guys were sitting here, and then Pete was sitting here because you guys moved that one from. Is it you?
Yeah, we
No.
Oh. Okay, it's okay. It's okay. We have a big classroom. You can sit anywhere you like. Yes. Okay, let's see. So we continue. You see this factor has no prime, then we just copy down, right? So we copy down 53x squared minus 5x to the negative 1 plus e to the 4x to the 49. Okay, now we need to differentiate. Wayne, what's the derivative of 3x squared?
that'd be 6x.
Yes, 6x. Well, what's the derivative of negative 5x to the minus 1? Yeah, very good. Dylan, what's the derivative of e to the 4x? Yeah, exactly. That's it. Okay? So we figure out the u, then we use the correct rule, chain rule. Okay? But when you read the u, don't write down the letter u, write down what exactly the u is. So far, so good, everybody? Yes. We will do a lot of examples today. Okay, here. So this function, do you see before we differentiate, you want to make sure all the terms in the standard form. And you see here, the standard form is for power function is a coefficient times x to the some power, right? But what is x times square root of x?
X negative to the power of negative x.
Okay, so this is x, and x square root of x is x to the 1 over 2. And when you multiply them, what do you get? What do you do to the exponents? Add them. So 1 plus 1 half is 3 half. So this is actually 5 e to the 7x, and then 4 times x to the 3 half minus 3. So far, so good, everybody? Yes, so when you take the derivative, okay, when you take the derivative, you look at the formats from the outside to the inside. And here you see the format is something over something is a quotient, right? So we use quotient rule. Okay, so quotient rule is, so you write down the u or v, okay? Just remember it's the top guy prime, right? So the top guy prime. So 5 e to the 7x, top guy prime times the bottom guy. And then what? Plus or minus? Minus. Then we have the top times the bottom. Prime. All over the bottom. Square. Is everybody okay with the quotient rule?
Like, should I tell you what the
The closure rule here?
Product including like
Here?
oh,
This is a closure rule. This is a product rule. So be familiar with all the rules we learned. Okay, everybody? It's actually 4 rules. But then today, the chain rule is you multiply by u prime at the end. Okay? Just one extra thing at the end. Mhm. Yes. Okay. And so every step just do one thing. This step we did quotient rule. And then the next step you look at which factor has the prime, you differentiate it. Right? Okay, the first factor has prime. Let's differentiate it. Mackenzie, what's the derivative of 5 times e to the 7x? So 5 times 7x. Do you have x there? See? Here. Do you move the kx? Do you move the x in front? No. Just k. Right. So just 7. 5 times 7 is, you can use your hand, 35. Yes. Okay. And the exponent remain the same, right? Everybody? We don't subtract 1 from it. And then 4x to the 3/2 minus 3 minus 5e to the 7x. Gabby, what's the derivative of 4x to the 3/2? Yes. Is everybody okay? Because 4 times 3/2, the 4 and the half cancel, you get 2. 2 times 3 is 6. And then x to the 3/2 minus 1 is 1/2. And derivative of a constant is 0. Yes, everybody? Mm-hmm. Okay, good. Oh, and that's it. We have the denominator. So 4x to the 3/2 minus 3 and squared. That's it. So far, so good. Actually, this problem, we don't need to chain rule. Yes? Mm-hmm. So let's continue. Okay, the next problem.
why you don't need to change?
Huh?
Why you don't need to change?
We don't have a composite function. So chain rule is when you have a composite function, like this. See this problem, something square. It's not just x squared. It's something else squared, right? Everybody. So this is the place we use chain rule. But we write everything in the standard form first. So 2x to the 7 plus 1 square. Key root. What is key root? Yeah, 1/3 to the 1/3. Okay, everybody? So when you differentiate from the outside to the inside, think about it's like a onion, and you peel off the layers. The first layer is a product, so you use product rule. Okay, everybody? So product rule is the y prime. Okay, when you differentiate, make sure you put y prime. Don't just put equal, because if you're saying the y equals to the derivative. No. The only function equal to its derivative is e to the x, and the constant function is 0. Okay? Those are the only 2 functions. It equals to the derivative. Mm-hmm. So make sure you put y prime. You can use dy dx or df ds. It's the same thing, but the derivative. Okay, first layer, outer layer is product. So product rule is first. So first factor prime times second factor. Yes, everybody? And then What's next? So first factor prime times second factor. Down J. What's next? Plus or minus? Plus. And then? Mm-hmm. Yes. Prime. Yes. Right, everybody? So the first step, we only use product rule. And you don't need to put UV there. Just make things simple. Okay, you have the UV in your mind, but you don't need to write it down on your solution. Okay, the first guy times second guy. The first guy times second guy. Okay, everybody? And now the next step. For the factor with the prime, we need to differentiate. And now do you see here, we need chain rule? Yes. So we need chain rule. So here, this is my u, right, everybody? Okay. This is like u squared. What is the derivative of u squared? Joseph, what's the derivative of u squared?
2
Yeah, so it's 2u times u prime, right? So 2u, don't put the letter u, put the the expression 2x to the 7 plus 1. So 2u times u prime. Is that okay, everybody? 2u times u prime. And this is just the first factor. And you keep going. So multiply the second factor. For the factor with no prime, we just copy down. Don't change it. Oh, you see here? We have another composite function, right? So this is my another u. What's the derivative of u to the 1/3? Page. Yes, 1/3, and then u. So write down the what exactly the u is. To the what? 1/3. U to the what power? Yes, negative 2/3, and then times u prime. So 3e to the 5x minus 2x to the 4 prime. Is that okay, everybody? See, here, you actually see the u 3 times. Because when you use the product rule, you have the u is the first term of the first factor of the product. And then we use chain rule 2 times. That's why I say you have the u in your mind, but don't write down the u. Write down what exactly the expression is. Okay, everybody? So you don't have the views of the picture. Okay, good. So for the factor with no prime, just copy that. And then we differentiate the factor with the prime. So let's see. So 2, copy down. 2x to the 7 plus 1, copy down. Layla, what is the derivative of 2x to the 7? Yes, 14x to the 6. And what is the derivative of 1? 0, yes. So yeah, this is it. So we continue to copy the factors with no prime. So 2x to the 7 plus 1 square, and this is 1/3. 3e to the 5x minus 2x to the 4 to the negative 2/3. Okay, 2/3. All right, now blank again. What's the derivative of 3e to the 5x?
35 e to the 5x.
Yes. And the derivative of 2x to the fourth? Yes, very good. See, after you make sure you get rid of all the prime, then you can stop. Do not need to simplify. Is that okay, everybody? Yes. So that is chain rule. And yeah, you look at the first layer. So see, the outer format was the product. So the first layer is like you use product rule. And then the second layer, when you differentiate this guy, you use chain rule. And the third layer, yeah, when you differentiate this guy, you also use chain rule. So it's like you peel the onion and then look at from the outside to the inside. Okay, everybody? Good. So keep going. Okay, look at the format from the outside to the inside. Do you see the outside is something cube? Yeah, so in this case, the outer format is a composite function. So we use the chain rule first. Right, everybody?
So would you just toss the 3 out of like when you're finding the chain rule, you would just toss the 3 out of the parentheses and then just do the whole questionable accurate?
Yes, right. So yeah, so next step, when you do the, because this whole thing is your u.
Yeah.
So when you do the u prime, you use quotient.
Yeah.
Yeah, very good. Okay, so we let this be u. And y prime will. What is the derivative of u cube? U cube derivative. U cube.
Oh, 3u to the second power.
Times. Remember, we always multiply by u prime. Yes. Okay, so if you kind of get confused by this complicated thing, you can write down this on your side notes. Okay? So now let's write it down. 3u. My u is e to the 2x over 3x squared plus 2 square root of x squared times u prime. U prime, we need to write it down again. But because the next step, we're going to differentiate, I want to make sure all the terms are in standard form. What is square root of x? X to the 1/2. Yes, prime. So step 1, we use chain rule. It's only chain rule in step 1. Okay, everybody? So the first layer is chain rule. Okay, imagine onion. Okay. Have you ever cut an onion? Yeah, okay. So a lot of layers, right? The first layer is chain rule. And then the second layer, you see? This is a quotient. We use quotient rule. Right, everybody? So let's write it down. We have 3 e to the 2x over 3x squared plus 2 square root of x squared. Okay, now quotient rule, Dylan. What's quotient rule? U prime v, so the top e to the 2x prime times v is what? Yes. And make sure you include the parentheses. Okay, everybody? Because without the parentheses, it will be wrong. And then plus or minus? Minus. What? Yes. U is, and then times v 3x squared plus 2x to 1/2 prime, right? All over the denominator square. So far, so good, everybody? See, every step we just do one thing. And we look at from the outside to the inside. So here, next step, copy it. Only differentiate the factor with the So we have 3 e to the 2x over 3x squared plus 2 square root of x squared. And let's see. We can see what's the derivative of e to the 2x. Very good. 2 e to the 2x. I hope you get that soon. Drink some honey and hot water. Honey. Oh, you have that. Okay, good. Yeah, it just takes time. I know. 2x to the 1/2. Okay, and then continue. See, copy down. The factor has no prime. Just copy down. And then here, Gabby. 6x minus x to the -1/2. So 6x plus or minus? So 6x plus. And the 2 and the 1/2 cancel. So it just has x to the -1/2. Right. And then the denominator has no prime. Just copy it. So far, so good, everybody? Yeah. So your problem can get more and more complicated, but it's okay. Just look at it from the outside to the inside. And every step, just do one thing. Don't jump steps. Promise? Don't jump steps. So like here, step 1, we did chain rule. Write down the chain rule. Step 2, we did quotient rule. Write down the quotient rule. And then next step, we look at which factor has the prime, and then we take the derivative of that. Okay, everybody? Do not simplify. Just leave your answer like this. Okay. As long as you have all the factor with no prime, then you are done for the problem. Okay. Let's continue. How about this? Let's rewrite it to the standard form. So 7 e to the 5. What's 4 roots? X to the... What's 4 roots? X to the 1/4. And then plus 11x to the 6. Right, everybody? We look at from the outside to the inside. You see, we get 7 e to the something. This is a composition function, right? Everybody, e to the something. Since we only have the formula e to the x, if it's not x, then we need to change the composition function. So we let this be u. Okay, so this is u. And derivative, J. What's the derivative of this? Do we have products? So 7 e to the u, what's the derivative? So what's the formula? E to the u, derivative is e to the u times u prime. So here, what happened with the 7? 7 e to the u, right? 5 I mean to the 1/4. Yes. Okay. So once you figure out that's your u, then this is just e to the u. E to the u is e to the u times u. Right, everybody? Okay. So the first step we use chain rule. The second step, let's figure out the factor with the prime. Okay. So this one has no prime, just copy it. Okay, Joseph, what's the derivative of 5x to the 1/4? Yes. Okay, Paige, what's the derivative of 11x to the 6? Yeah, 66x to the 5th. And we're done. See? Now all the factor we don't have prime anymore. Then we finish this problem. So far so good, everybody? So be familiar with 4 formulas. X to the n, derivative is n, x to the n minus 1. And then e to the u, derivative is e to the u times 2i. And you have product rule and quotient rule. Yes. Okay. What happened when we have something like this? So remember, Anya, you peel off the layers, right? You look at the outside. Outside, oh, you see this is like something to the square root is what? 1/2, right, everybody? So we look at from the outside to the inside. So we let the inner function be u in the first step. Right, everybody? Okay, y prime. Layla, what's the derivative of u to the 1/2? U to the 1/2? 1/2, and then u, right? To the, so you write down the u to the 1, you mean minus 1/2? Yes. And then times u, right? U prime. Is that okay, everybody? All right. So yeah, so you're doing u to the 1/2 prime is 1/2 u to the negative 1/2 times u prime. So using this. So sometimes if you're not quite sure, you can write the rule down in your like scratch paper or side notes. That's you. And then the next step, you want to differentiate this guy, right, everybody? We want to differentiate this guy. It's not in the standard form, right? So let's rewrite it to the standard form. This is like, this guy is x plus square root of x to the 1/2. Right, everybody? Square root is that thing to the 1/2. Okay. So we continue. So 1/2, leave it here. And then this factor, leave it here. And then you want to take the derivative of this guy, right? Let's see, who's next? Sure.
This is doing standard form
Oh, yeah, we can put this x to the 1/2 later. Yeah. Right now I'm just changing it as needed. So, right. So I change it as needed. But you're right. You can put this guy to the 1/2 and this guy to the 1/2 and then this guy to the 1/2. You can do that. It's the same thing. Okay, everybody? Up to you. You can change everything to the 1/2. But then if you change everything to the 1/2, there are a lot of parentheses there. So I just want to make it look nicer, less parentheses. So I change it as needed. Okay, everybody? Alright. So let's see the derivative. And who's next? Are you the next? Did you answer? Okay, you do it. Okay. What's the derivative of x? Yes, 1. Right, everybody? Linear function. The derivative is just the coefficient. Plus, you see this guy is a composite function. It's gonna be chain rule with u with the inner function, right? So this is the u. So what's the derivative? 1/2 x plus square root of x to the negative 1/2, and then
And then you got x plus square root of x plus square root of x.
and then
Oh, and then
prime, yes.
and then parentheses. So here, the common mistake is student might forgot the parentheses. Do you see this u prime? You only multiply by this factor. Do you multiply it with the 1? No. So don't put your parentheses here. Put your parentheses here. Because this u prime is only for the derivative of the second term. So you only multiply the second term by the u prime. Your first term, just 1. Okay, everybody? So I think this problem, you gotta be careful with the location of the parentheses. Alright, we almost there. See? Here. We want to differentiate this guy, then you want to make it into the standard form. Right, everybody?
Yes. So this is x to the 1/2. Now we differentiate. So the factor with no prime, we just copy it. The factor with no prime, just copy it.
Okay, Steven. This guy has prime. So what's the derivative?
1 plus, yes. And then close parentheses, and then another parentheses.
Okay, everybody? Yeah. So this problem, the feeling is really like you peel off the layers of an onion, right? So yeah, inside. So we use chain rule multiple times. So far, so good, everybody? Yeah.
Okay. Example 2. Find the second derivative of this function. Ooh, second derivative means you find the first derivative and then you take one more derivative. Right, everybody? So let's see.
Is it in the standard form?
No. Square root is what? 1 plus x cubed to the 1/2. Right, everybody?
Okay, so when we differentiate
Do you see this is a composite function? Mm-hmm. What's your u? Your u is, yeah, 1 plus x cubed. So your y prime is, let's see, half to the power, what? 1 over 2, but minus. And then times what u prime, 1 plus x cubed prime. Right? Gabby, what's the derivative of 1 plus x cubed? 3x squared. Yes, everybody? Oh, okay. So usually when I ask you to find the derivative, you don't need to simplify. But if I ask you to find the second derivative, you'd better simplify your answer for the first derivative. Do you agree, everybody? You make it look nicer. But I would say, let's combine the 1/2 and the 3x squared together. So you have 1 plus x cubed to the minus 1/2 times 3 over 2 x squared. So I just moved the 1/2 together with the 3x squared. So it looks simpler. Do you see now the format is something times something? I get a product. I like to have the power to be negative, but I like to have this term in the numerator. Then I only do product rule. But for this problem, you can also put this in the denominator, then your power becomes this guy to the 1/2. Then you use quotient rule. But do you think product rule is easier or quotient rule is easier? Huh? Product rule, right? Quotient rule, you have the denominator square. So that's why I would keep this in the numerator. Even though the exponent is negative, that's okay. All right, everybody? So y prime prime. Y prime prime is, so we have product rule. So first guy, prime, times second guy, plus first guy, times second guy, prime. Is that okay, everybody? Good. Okay, first guy prime. You see here, we get a composite function. Then we need to let this be u, right? Yes? So looking from the outside to the inside. Here, we need to do the chain rule. What's the derivative of u to the minus 1/2? U to the minus 1/2 derivative is, so what's the power rule? Minus 1/2, right? And then u to the what? Negative 3/2. Yes, everybody? And then times u prime. Is that okay, everybody? Composite function, power rule, and times u to the n minus 1 times u prime. Okay. And then 3 over 2 x squared, copy it. 1 plus x cubed to the minus 1/2, copy it. What is the derivative of 3 over 2 x squared? 3x. Yes, the 2 and the 2 cancel. We get 3x. Is that okay, everybody? Almost there. So if you don't like to simplify, it's okay. I don't require you to simplify for the last answer. But what's the derivative of 1 plus x cubed? 1 plus x cubed derivative. Yes, 3x squared. Very good. And you multiply by 3 over 2x squared. And just copy all the factors down. So you can leave your answer like this. Okay, it's okay to not simplify. But if you want to simplify, totally okay. So you can combine them and you get minus 9 over 4x to the 4. Okay, so up to you. If you want to combine them, you get negative 9 over 4x to the 4. Just rewrite again. Okay, so the next week we will continue with this worksheet and we will start 4.4 and 4.5. Okay, so have your 4.4 and 4.5 worksheets as well. Okay, yeah. Have a nice weekend and do your homework. So we postpone the homework, right? Mm-hmm. Wednesday. Yes, next Wednesday. Bye. Hmm? No, we're behind schedule. So Monday will be 4.4 and 4.5, and we don't have time for review. So review is you study at home. But all the practice assignments are on the website. Yes. Thank you.
So we're still gonna do it next week.
Huh? We probably need to move down, postpone it. Yes, I will see. Yeah, when do we have? Probably move to, yeah, move the quiz and then probably move the exam as well. Yeah. So we'll talk about that next week. Mm-hmm.